Hi everyone, my name is Mohan Teja, and from today onwards, I'm planning on doing lead codes to improve my problem solving skills. And I want to improve my skills in such a way that it's most optimized for job interviews, right? So for that, I'm starting with top interview questions. Over here, you can see if I this is the problem set in the lead code, and instead of solving one by one, which is not that optimal. Instead, we can just go with the top interview questions. You can see here, these are all the top interview questions of 150 interview questions that are most asked in companies such as Google, Facebook, like fan-based companies, right? So we are going to start with the first problem here. You can see it's also categorized. It covers every single topic from arrays to pointers, sliding windows, matrix, and also you can see dynamic programming as well. If you go down, there are graphs and trees and divide and conquer like that. It covers one-dimensional dynamic programming and multi-dimensional dynamic programming and 3D methods as well here. Like divide and conquer, backtracking, and etc. Right? So basically, we're gonna solve this one by one, and we're gonna start with the first problem here, which is merge sorted array, which is one of the arrays based problem approach, right? And we can go through here. As you can see, I'm gonna use Python to solve the problem. And here is the problem statement, which is you are given two integer arrays, nums1 and nums2, and sorted in the non-decreasing order, which is sorted in the increasing order. And two integers, m and n, representing the number of elements in nums1 and nums2 respectively. Right? Our task is to output nums1 and nums2. Our task is to merge nums1 and nums2 into single array sorted in non-decreasing order, right? So here nums1 is already sorted and nums2 is already sorted, but our task is to combine those nums1 and nums2 and sort that uh, output array, right? And we need to sort in such a way that there is one more condition. As you can see, the final sorted array should not be returned by the function, but instead it should be sorted inside the array nums1, which is called in placing. We should sort in place of nums1. The reason why here, I think it's testing for our space complexity. Instead of taking new array, because just sorting these two elements, two arrays, and putting them in the new array is very easy. That's the first approach we will think of, right? Kind of brute forcing way. We're gonna solve using taking the new array as well. We're just gonna solve that approach as well. But here to accommodate, here you can see to accommodate this, nums1 has the length of m plus n. As you can see here, it has the length of both m plus n, the total length of nums1, which will make a lot easier for us to solve this problem. And where the first m elements denotes the elements that should be merged, and the last n elements are set to 0. And should be ignore nums2 has a length of n. I mean set to 0 and should be ignored. And nums2 has a length of n. And we can, if we look into the example one of the examples, right? Here you can see nums1 is given, input nums1 is given, and the length of nums1 is 3. As you can see, the first three elements are non-zeros, like greater than 0, and that is the original, only the array length of nums1, and rest of the array elements in that array are set to 0, which will make very easy for us to solve this problem. And the rest of the elements are the length of nums2, which is 2, 5, 6, as you can see, and equals to 3 here. So the final output should be, those two should be combined, the nums1 and nums2 should be merged, and that merged array should be sorted using merge sort, right? Here 1, 2, as you can see, 1, 2, and there is 2 here. There's one more 2 here. That's 2 is merged here. And 3, sorry, here you can see 3. And here you can see 5 and 6 as usual, because those are the last elements. Those are biggest elements, right? So that's the output we need to present, and we should not return the output. Instead, we need to update the nums1 itself. We need to update nums1 such that it is merged with nums1 and nums2 and sorted, right? That's the output we need to do. For that, we can go with, there are multiple approaches, right? So there is a brute forcing, which we talked about, like taking a new element, extra array, and we can just combine nums1 and nums2 in the merged sort. And we can, to in place this, like we can return nums3, but to the as the problem statement says, that we need to change nums1 such that it is sorted. So what we can do is, there's a trick, like we can merge that in nums3, and we can copy the elements of nums3 into nums1, so that nums1 will be the sorted array, right? That's kind of brute force approach that I came whenever I saw the problem. That's the first approach I came with. So let's do that by solving this problem, right? For that, as usual, we're gonna take new element, and for tracking the first nums1, we're gonna track with I, that's starting with 0, and we're gonna track z, starting with 0, right? And while I less than or equal to z, less than or equal to m, and j is less than or equals to n, right? We are starting from 0 and going till m for nums1, and we are starting from 0 and going till n for the nums2, right? We're going to check which one is greater. If nums1 is less than or equals to, or yeah, less than or equals to nums1 of I, right? If it's less than or equals to nums2 of j, what we're going to do is we're going to append the nums1 value, because nums1 value is smaller in this condition. So we're going to append that nums1 value into nums3, and we're going to do is I plus equals to 1. Else we're going to append nums2 value here. We're going to append nums2 of z here, right? So that's what we're going to do, and j plus equals to 1, and that's nums3. But here you can see we are going to I less than or equals to m, and j equals less than or equals to n. If one of those conditions satisfies, the loop will be ended. So there might be a case where I is still greater than, I mean, greater less than m, which is not equals to m. So what we can do, while I, all right, let's just use if condition here. If I less than or equals to m, what we can do is we can extend. Instead of appending, we can just we can use append while I is less than or equals to m, and we can just I minus equals to 1, and we can do that. But instead, we already know that we can just extend it. Nums3 dot extend nums1 of I till m, right? We're going to do the same to the j as well, because j also could be the condition where it could be less than or equals to n, right? So it's the same, j to n for nums2, and then we can just copy nums1 equals to nums3, right? Uh, let's see how it's gonna go. Oh, okay, listing this out of range. Huh. Something nums1 pi, which is 0, right? Nums1 of 0 is less than or equals to nums2 of 0. Right. Huh. Minus 1, is it? Uh, Maybe minus 1. Let's just test. Because we are testing till nums 1 and nums 2 will start. Yeah. 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 If that's the case, then we should do this as well. Or you know what? We can just remove equal to and we can just do this. Both are same pretty much. Yeah, both are same pretty much. Yeah, we can just do this and we can run and see. Hopefully, no errors. Yeah, okay. 1, 2, 3. Okay. Yeah, I think the reason is nums one equals to nums three. It's here. What we are doing is if we are just copying the nums three. We are taking new array here in the new space. Nums three is the new array that is in the new memory. So instead we need to in place the current array. Here the current array nums1, we need to in place it. For that, what we can do is for k in range of, we can copy one element at once. Uh, Here we can say nums1. Oh, right, nums len of nums3 or n plus n, right? I think n plus n works, and we just copy the elements, each element from each copy each element of nums3 to nums1, right? And then we check here. Yeah, there you go. It works, right? So if we submit and see, the time complexity is very good here, right? You can see in the description. Once we go into the description, we need to, can you come up with an algorithm that runs it O of m plus n? Actually, this runs with O of m plus n. Let me explain here. As you can see, the runtime is 0 ms and beats 100%, right? Here, you can see we're just running it. As you can see, time complexity, I mean, let's just say time complexity is running in O of m plus n, right? If you are seeing over here, O of m, in fact, it's running at most is O of n plus 1. It's running less than that. It could run less than that. And here also, because it runs extra time over here. So basically, this entire code is running with O of n plus n, but we are taking extra space. O of same space is going with O of m plus n as well here, right? We are doing this and we are doing the same over here as well. So that's why the time complexity is working good. That's why we are beating 100% of the people. But that space complexity here, we are taking extra space for nums3 to merge two elements, two arrays, right? So this is optimal for time, but not as optimal as the problem asks. So we can solve this in other approach, which is pretty much using, there is no need to take an entire new array. Instead, we can take one variable and we can track that one variable for merging the two arrays in place, right? We know, for example, we already know that nums1 is already sorted and nums2 is already sorted, which is our advantage here. And also we also know that nums1 has the length of m plus n. We can use that here and we can solve from the back. From the back onwards, we can merge it. For example, we will check, we will take I as here as m minus 1, which is 2, and j here as n minus 1 equals to 6. And we will compare 3 to 6. Whichever is highest, we're going to put that in this. We're going to take k equals to m plus n minus 1, which is here 5, and we're gonna put nums1 of k, which is 5, between 3 or 6, whichever is greatest, we're gonna put over here. So the 6 will go here, right? So, and then we're gonna compare, we're gonna keep this as it is I, but j, we're gonna move it to before element, j minus equals to 1. And here we're gonna compare 3 to 5. We know that 5 is greater than, again, we're gonna put 5 over here and we can compare 3 and 2. We know that 3 is greater than, we're gonna put 3 over here and we're gonna move I to 2 here. Like that we're gonna solve it, right? That's most optimized solution I came up with, because it's not using, I thought this is optimized, but I thought that I I think there is more optimized solution than this, instead of taking new space over here. So I thought of doing that. And yeah, let's see. We're gonna take k, m plus n, m plus n minus 1. Obviously, I equals to m minus 1, right? And j equals to n minus 1 for tracking nums2, right? So here, same, I think we can just copy paste this pretty much, or we can write the code over here while I is less than or equals, or yeah, we are taking m minus 1, right? So less than, less than 0, less than or equals to 0, I guess. I believe less than or equals to 0. And all right, and j less than or equals to 0, right? So all right, so I is less than or equals to 0 and j is less than or equals to 0. And then we're going to check nums1, whichever is highest here. We need to check whichever is highest, greater than or equals to nums2 of j. If that's greater than or equals to nums2 of j, then I mean, if we need to add if here, if condition, right? Then nums1 of k equals to nums1 of I, and then I minus equals to 1, right? Else we're gonna do copy this and we're gonna put j value, I mean nums2 of j at k, nums2 of j at k, and j equals to j minus 1, right? So obviously we're gonna do k minus 1 for every single step. And then yeah, that's pretty much it, will solve it. And yeah, I think it should, that's it, that's the code, that's pretty much, it will give the required output here. Yeah, I put them in comments. Again, listing that's out of range, less than, let's just say less than, uh, because it will go minus one, I believe. Yeah, again, 1 2 2 3 5 why is it not happening? Okay, I believe, I think is less than 0. Let me solve this. Uh, k is equals to nums1 of nums2 of j, j minus equals to 1, k minus equals to 1. Let's just run this. It should work, I believe, because oh sorry, less than 0. Okay, all right. Still that's out of French. Oh really? Uh, okay, k equals to m plus n minus 1, I equals to n minus 1, j equals to n minus 1. So while I is less than or equal less than. Okay. Um, all right. Should be greater than or equals to. Right. It should be greater than or equals to. Right. Huh. Should be greater than or equals to. Okay. Because we are starting from the end, right? So every time the condition becomes true when I is positive instead of zero. So let's just run and see. Uh, yeah, there you go. Should work. And again, why I'm adding this and also why I'm not adding while I is greater than or equals to zero because uh, we all know nums1 is already sorted. It's already in the sorted area. So there is no need to sort with I again as like before here we might know I could be less than m and the condition it could still be there j could be less than n there still could be there the same condition it will happen here I could be greater than still could be greater than or equal to 0 and j could be still greater than or equal to 0 but there is no need to sort I greater than or equal to 0 because nums1 has already sorted with I. So that's why we are checking this condition with j one more time. J is greater than or equal to 0. Let's just see if I if I don't do that. There will be some test cases that will not be accepted. Like that will not give the output. So yeah, you can see here. Here nums1 is 0, nums2 is 1, and here both conditions I is greater than or equal to 0. Here I is greater than or equal to 0, j is greater than or equal to 0. In first condition itself, they will not be sorted right in the first condition itself. So they will go to they have to be checked with this condition. So the output here will be 0. The output we got here will be 0 as you can see, but the expected output should be 0 comma 1. So the nums1 already have sorted 0, so there is no need to sort it with I again. So that's why we are adding this j greater than or equal to 0. Then it will, you can see nums1 of k, which is nums1 of uh, there will be 0 here as you can see there will be 0 nums1 of k will be 0 comma 0 here and we will add nums2 of j which will be 1 so the output will be 0 comma 1 so if we run this and check we're gonna get the accepted test cases here 0 comma 1 right so the 0 will be replaced with the 1 right so that's it that's how it will work here. Well, I believe I explained it wrong in the last test case because the 0 that means nums1 has no elements in that last test case right here you can see nums1 is 0 that means there is no elements in the nums1 and nums2 has an element of 1 so we need to put this 1 in the nums1 so yeah even in the condition I mean in the approach we took it acts as the same right so that's the solution as you can see here we beat almost 74% here in the memory we're just taking one variable here extra and here one I one j so pretty much we are getting time complexity of O of m plus n as you can see because we're taking the same approach here. We're taking here the approach is same, whatever the approach we took, it's the same. So the time complexity will be pretty much same, but the space complexity, as you can see, the space complexity of is O of 1. That's all. We are not taking any extra space at all. We're not taking any arrays. Arrays will take extra space if we add more elements in it as we are not adding any elements to any array so it's going to be O of 1 so that's it this is my approach in solving this problem hope you learned something from it I learned something from it so I this is my first problem and that's exciting so I hope I will solve more problems in the future every day I'm planning on solving one problem and explain my approach here so that others can learn something from it. Yeah. So thank you.